Okay, good day. This is Math 140 College Algebra. I am Professor McCulley. This is lesson 1.8, linear inequalities. So let's get right to it. Today, we are going to represent linear inequalities in one variable, and the students are going to solve linear inequalities in one variable. Students will solve problems involving linear inequalities in a single or just one variable. So what does that mean? Linear inequalities, some things to remember. Solutions are usually an interval, not a single number. So it's a little bit different than if we're solving an equality, a linear equality in one variable. We usually get a single value. Finding solutions is similar to solving linear equations in one variable. And so we're going to follow that same order of operations. That please excuse my dear Aunt Sally. We'll be doing that. But the one thing that we do have to keep in mind is when solving, multiplying or dividing both sides of the inequality by a negative, you must change the inequality signs. I think I need a parenthesis or a comma maybe right there. You will put a comma. When solving, comma, multiplying or dividing both sides of the inequality by a negative, you must change the inequality sign. That seems a little bit better. Let's talk about that. So the first thing we're going to do is we're going to solve the linear inequality, and I'm going to follow my regular order of operations when I go to do that. So the first thing I'm going to do is I'm going to say, let's bring the 2x to the other side. So subtract 2x from both sides. And that'll give us just 1x. So 3x minus 2x is 1x, plus 1 is greater than or equal to 0. And then I think we're going to subtract 1 from both sides. And that'll give me x is greater than or equal to negative 1. And so what this says is that any value for x that is greater than or equal to negative 1 will make this true. So let's pick a value as a simple check. Let's let x equal to 3. 3 is greater than or equal to 1. So 3 times 3 plus 1, is that in fact greater than 2 times 3? Well, 10 is certainly greater than 6, so that's a true statement. And now that's not necessarily a proof that our solution is correct, but that does give us an idea that it is in fact correct. All right, let's solve another linear equality here. And so the first thing I'm going to do with this particular one here, let's move that over just a little bit. And the first thing I want to do here is I think I'm going to distribute. And that'll give me 2x plus 7 is less than 3x minus 12. All right, and let's move, and I'm doing this on purpose. I'm going to move the 3x to the left. And I'm going to have to do that with subtraction. And so what that'll give me is that'll give me negative x plus 7 is less than 3x minus, or oops, I already moved the 3x, so is less than negative 12. And then I'm going to subtract 7 from both sides. And that'll give me x is less than, and I subtract negative 12 minus 7 is negative 19. And then I have to divide by negative 1. Let's just make it negative 1 here. I divide by negative 1. And from the statement above, that number 3 from the last set of notes here, says that I need to change the symbol. So I need to remember to change the inequality symbol. And so look at me, x is greater than positive 19. And so what this says is that anytime any value for x that's greater than 19 should make that true. And again, we could check that. So I want to pick 20. 20 times 2 is 20, or is 40, excuse me. Plus 7 is 47. And then 20 minus 4 is 16. And then 3 times 16 is going to be 64, which is in fact less than 47. So we are good there. And we can move on. Okay. Solving a linear inequality involving an absolute value, there are two basic forms. And so what this says is the solution of the absolute value of x is less than a, all the values between x and, a and negative a. And so what that tells me is that the distance between this expression and 0 is less than a units. Similarly, the solutions of the absolute value of x is greater than a are all the values that are less than negative a and greater than positive a. So whenever we see a absolute value inequality that looks like this, we're going to set up the compound inequality to solve. And that is for both this one and that one as well. So let's do a couple of examples of that. Says solve the following absolute value inequality and graph the solution. So the first thing we're going to do is we're going to solve it. Since this is a less than absolute value inequality, we are going to look and we're going to use this form right here since it's the less than. So what we're going to do is we're going to say that negative 6 is less than 2x plus 4, which is less than 6. All right, so this is my compound. I didn't spell that right. C-O-M-P-O-U-N-D inequality. And so what we're going to do is we're going to solve this as if it were an equality, but instead of having just two sides, it's got three sides. It's got this left side, it's got a middle side, and it's got a right side. So first thing I'm going to do here is I'm going to subtract 4 from both sides. And so negative 6 minus 4 is negative 10. It's going to be less than 2x. And then 6 minus 4 is going to be 2. And then I'm going to divide by 2. And so negative 10 divided by 2 is negative 5. It's going to be less than x. And then 2 divided by 2 is 1. And so this is the solution right here. And then they want me to graph that solution. Okay, so let's get a number line here. We'll just make a quick, simple number line. And so this says all of the values between negative 5 and positive 1 exclusive. We're not including them because it's everything that is less than, or greater than negative 5 and everything that's less than positive 1. So we could do it a couple of different ways. One way we could do it is we could put an open circle there at 1 and an open circle there at negative 5 and say we're going to use these values here. And if you don't like that, you can use what's almost looks like interval notation. Instead of an open circle, we can use a parenthesis on both sides at 1 and negative 5 and all of the values that is included inside that. So that's one way to do it. Here's another one where we have an absolute value inequality that has a greater than symbol. But we also note that there's a 3 outside the absolute value. And so we have to deal with that first. All right, so we can't set up the compound inequality. Where'd that go? We can't set up these compound inequalities until everything is gone from the absolute value. I have to deal with that last. All right, so we're going to divide by 3 first. All right, so when I divide the left-hand side by 3, the 3 will cancel, and then 9 divided by 3 is going to give me an absolute value of 4 minus 5x is greater than 3. All right, and now I'm going to set up the compound inequality. And because it is a greater than symbol here, we're going to use this compound inequality. And so we're going to take the expression and set it less than the negative value outside and the expression greater than the positive value on the outside there. All right, so let's see here. It'll be 4 minus 5x is less than negative 3, or 4 minus 5x is greater than positive 3. And then we're going to solve each inequality separately. All right, so I'm going to, let's see here, we're going to subtract 4 from both sides. So I got negative 5x is less than negative 7, or negative 5x is greater than negative 1. When I do that, and then I got to divide both sides by negative 5. And remember, we have to switch the signs. And so we'll get x greater than, that's to be positive 7/5, or x is less than positive 1/5. And we should probably rewrite that thing. And clearly, and you'll notice here, clearly 7/5 is greater than 1/5. So if we wanted to do it right, if I mark this on my number line, and this is my solution, by the way. Let's do a better job. There we go. There's my solution. Clearly, 7/5 on a number line would be greater than 1/5. And again, because it's just a less than symbol, we're going to use a parenthesis there. And the values of x that are less than 1/5 would go this way. And the values of x that are positive or greater than 7/5 would go this way. And that is my graph. All right. Finally, it says use the graph to write an absolute value inequality. And so if this is 45, 1, 2, 3, 4, that would be right here is going to be 49. And if I go back 1, 2, 3, 4, that's going to be 41. And so we want to write an absolute value inequality. And so clearly this is going to be, because it's an interval that's doesn't go to the left and to the right, it's just a segment of the number line here. Well, we clearly know that it's going to be some value x minus b is going to be less than a. All right, and so when you think about it in that terms, this thing says that the distance from x or from b to x is less than a units away. So here is my a units, and here are my a units. So what's halfway in between, this is going to be my b value, and that is going to be the possible distances. X is less than that many distance. So any of these values will be less than a units away from b. And so we can finish this off by saying x minus that center value is going to be 45. And the distance, so either way, 1, 2, 3, 4, or 1, 2, 3, 4 is going to be less than 4 units long. And that is how I'm going to set that up. And if it was going the other way, so just as a real quick example, if I had one that was let's say it looked like this, and we'll still do the same values. We'll do 45 here, we'll do 41 here, and we'll do 49 here if it was like this. And I'm using the brackets instead of the parentheses so that I can include a greater than or greater than or equal to symbol. The brackets are going to be for greater than or equal to, and so we'll have the absolute value of x minus 45. In this particular instance, it's going to be greater than or equal to 4 units long. All right, and that is the solution to that one. Oh, that's all I got for today, folks. So the Marvel fun fact of the day is this. Over the last 12 years, the MCU movies have grossed over $17 billion. That's more than Star Wars, Transformers, and the DC Extended Universe combined. That's all I got for today, folks. Have a good one. Bye.